Okay, so today we're going to go over a few more U-substitution problems. Okay, so these questions aren't too bad, but they do show why we use U-substitution and how to do the manipulation to get what we want. So let's take a look at the first one. Okay, so example number 1, we have the integral of 1 over 1 plus root x to the power 4 dx. Okay, we want to try and integrate this. Now, just looking at this, it's not one of those simple integrals that you can just write down, like with the power rule or trig functions. Those antiderivatives are easy to find and quickly write down. Here, this is something a bit more complicated. Okay, but the way U-substitution works is we need to look at what is making this complicated. So if we just had 1 over something to the 4, for example, just something like 1 over x to the 4, something like that, that's pretty easy to do because that's just a power rule. But over here, we've got something that's making it more complicated. We've got this 1 plus root x. Okay, what we want is something like 1 over x to the 4. That's easy. Here we've got 1 over 1 plus root x all to the power 4. So what we do is we substitute this complicated expression for another variable to make it easier. So we say u is equal to 1 plus root x. Okay, so why? Because the idea is that we want something like 1 over u to the 4, because that's easy. Okay, so that's the idea that we're trying to do. We let u be this complicated part inside so that if we replace this with u, it makes it easier to solve. Okay, so let's just put this in a cloud. This is the idea we want to do. Okay, but we can't just replace it like that because we've also got this differential here, this dx, we need to replace. If we replace the function with the variable u, then the differential also needs to be replaced with the variable u. So in this case, du is going to be, if we take the derivative, it's going to be 1/2 x to the minus 1/2 dx. Okay, but if we look here, we don't have that in our integral. So we take it over to the other side. We end up with 2 root x du is equal to dx. Okay, got a bit of a problem here because on the left-hand side here, we have x variables and u variables. We don't want that. We want only u variables there. So that's not too bad to fix because we know that u minus 1 is equal to root x. That's from over there. So we can just do that replacement. So we end up with 2 times u minus 1 du is equal to dx, okay, which is what we want. We needed to find dx. Okay, so let's do the substitution now. We know the replacement for the function and we know the replacement for the differential. So our new integral becomes 1 over 1 plus root x to the 4 now becomes 1 over u to the 4, and dx now becomes 2 times u minus 1 du. Okay, so this part replaces the function, this part replaces the differential. You always need to replace both. Okay, so now with a bit of manipulation here, we can make this look like a very nice power rule situation. So the 2 we can take out. We're left with the integral of u over u to the 4 minus 1 over u to the 4 du. Okay, but that's pretty straightforward because u over u to the 4, that just becomes u to the minus 3, and 1 over u to the 4, that becomes u to the minus 4. Okay, but that's just the power rule. So what do? We add 1 to the exponent to get a new exponent and then divide by that new exponent. So we end up with 2 times minus 1/2 u to the minus 2 plus 1/3 u to the minus 3 plus c. Okay, remember, always add plus c if we've got an indefinite integral. So this becomes minus u to the minus 2 plus 2/3 u to the minus 3, again plus c. Okay, but we're not done yet because now we've got an answer in terms of u, but what we really want is an answer in terms of x. Okay, so we need to put that back. So u is equal to 1 plus root x. So u is equal to 1 plus root x. We can just substitute that in and we get our final answer. So this is going to be minus 1 plus root x to the minus 2 plus 2/3 1 plus root x to the minus 3 plus c. Okay, so we've always got these 4 steps here. So we need to identify what u needs to be. Usually it's whatever the complicated inside part is. So in this case, the complicated inside part is 1 plus root x. So we let that be u. Step 1. Then we need to replace the differential. So we have dx, we want du. So we need to do that. There we find out what dx is so that we can make that replacement. Then 3, we replace the function with the function in terms of u. That's this part here. And we need to replace the differential with the differential in terms of u. So that's this part here. Okay, so the function of x changed to a function of u, and the differential dx changed to the differential with du. Okay, then we integrate in terms of u, but remember that we can't leave it in terms of u. We need to change back to x. Okay, so that's always your last step. All right, any questions on this example? Okay, someone's asking, please re-explain. Okay, no problem. Okay, so we're just going over this example again. So we have the integral of 1 over 1 plus root x, all of this to the power 4 dx. Okay, so we look at this for a bit and we realize that if this inside part here, this inside part, if that stuff wasn't there, then this would be really easy. For example, if we only had 1 over x to the 4. If we had that, this would be super easy. But it's not just 1 over x to the 4, because we've got this inside function, the 1 plus root x, that's making it more complicated. So what we do is we try and get rid of that inside function. So how do we do that? We replace this inside function, the complicated part, with u. So u is equal to whatever that complicated part was, 1 plus root x. Okay, sorry, I got another question here. Do we put our student numbers towards the end of the lecture? You can put your student numbers whenever you like. As long as I have it in the chat, then I can see that you've been here. Okay, so you can put your student number now if you like. Okay, so we make this replacement of this inside part with u. In other words, this function of x is now going to become a function of u. But remember, we can't just change the function. We've also got this part here to change. This dx, that also needs to change. So let's find out what dx needs to be. So we've got u is equal to this function of x. We can then find du. So du is going to be the derivative with respect to x. So it's going to be 1/2 x to the minus 1/2 dx. Okay, we can rewrite that. That's du is 1 over 2 root x dx. Okay, but we don't want 1 over 2 root x dx, we want dx. Okay, this doesn't help us yet. So we take all of that over to the other side. 2 root x du is equal to dx. Okay, almost there. We've got dx like we wanted, but if you look on the left-hand side, we've got x variables and u variables. That doesn't work. We only want one thing. So we need to replace root x with something involving u. So how do we get root x? Root x is u minus 1. So let's just make that replacement. So now we get 2 times u minus 1 du. Okay, everything's in terms of u. We're happy with that. Is equal to dx. Okay, so we've got the two things we need. The replacements in terms of u and the replacement of dx. Okay, those are the two important things we need. So let's make the replacement. So we have the integral of 1 over 1 plus root x, all of that to the power 4 dx. Okay, this first part, we need to write in terms of u. How do we do that? Well, 1 plus root x is u. So we just replace it. That's 1 over u to the 4. This part we need to replace. How do we do that? Well, we've got dx is equal to 2 times u minus 1 du. So we just make the replacement. Okay, now we've got an integral in terms of u. So this is going to be 2 times the integral u over u to the 4 minus 1 over u to the 4. Okay, so let's just simplify with the exponents there. So u over u to the 4, that's u to the minus 3. 1 over u to the 4, that's u to the minus 4. Okay, now we just use the power rule. So that's going to be 2 times. We add 1 to the exponent to make it minus 2. Divide by that, so we get minus 1/2 u to the minus 2. Next one, we add 1 to the exponent to make it minus 3. Divide by that, so we have plus 1/3. And don't forget your plus c. Okay, indefinite integral, you need to add your plus c. So this now becomes minus u to the minus 2 plus 2/3 u to the minus 3 plus c. Okay, but we're not done yet. We've got our answer in terms of u, but remember the question was in terms of x. So we need to put x back. So u is equal to 1 plus root x. So wherever we see a u, we can put 1 plus root x. Okay, so we just make the replacement, and now we're done because everything is in terms of x now. Okay, so you can't leave your answer in terms of u. That was just a middle step. We want the final answer in terms of x. Okay, let me just check the chat, see if there's any more questions. No. Okay. So any other questions on this example? Okay, let's just check here. No, okay, no more questions. Okay, let's take a look at the next one. Example 2. Okay, so we have the integral of the natural log of x, all of that squared, over x dx. And we want to try to figure this out. Now, again, we've got this problem of functions inside other functions, because we've got the natural log of x, that's one function, but then all of that squared. So it's a composition of functions. So that gives us the hint that we need to use U-Substitution. Okay, so what should we let u be? Well, u should be the inside function, because remember, we're trying to make it easier by letting the inside function be a simple variable u. okay, like we did in the previous example. So here, this inside part, natural log of x, that whole part we need to replace with u. That will make it simpler. Okay, so that's the idea. So we let u be the natural log of x. So that means this top part will become u squared, okay, which is a lot simpler than the natural log of x squared. Okay, but we can't just do a replacement like that. Remember, we also need to replace the differential. Okay, you can't just leave that. So we need to find dx. How do we find dx? Well, we've got u in terms of x, so we can find du. So du is the derivative of the natural log of x, which is 1 over x, dx. Okay. Now notice that's very nice, because if we look here, this integral we can write as the integral of the natural log of x squared times 1 over x dx. Okay, I just took that fraction out to the side. But if I highlight that, this 1 over x dx, okay, that part in blue there, that's this bit. Okay. In other words, that whole blue part, 1 over x dx, we can replace with du. Okay, because it looks exactly the same there. Okay, and then this natural log of x, we can replace with u. Let's check that part there. That can be replaced with that there. So let's make the replacement. So the integral of the natural log of x, all of it squared, times 1 over x dx. Let's do the replacement. The natural log of x, we're going to replace with u. So the natural log of x squared becomes u squared. 1 over x dx, that gets replaced with du. Okay, so you see after the two replacements, we replaced the function and we replaced the differential. There's always those two things to replace. We get a much simpler expression, u squared du. Okay, that's very easy to do. It's just the power rule. We add 1 to the exponent to make it 3, divide by that. So we get 1/3 u cubed, and this is indefinite, so we need to add c. Okay, but we're not done yet. Remember, this was just the middle step, evaluating in terms of u. We need to go back to what x was. So in this case, u was the natural log of x, so we just put that back. Okay, so everything's done because we're back in terms of x. Okay. Any questions about this one? Okay, let's have a look at the next one. Okay, so this is number 3 for the indefinite integrals part. We have the integral of 1 plus x over 1 plus x squared. Okay, so we want to try to figure this out. Okay, so this is a bit more complicated than before, but not too much. So we have 1 plus x at the top, and we have 1 plus x squared at the bottom. Now, there's no easy way to pick what u needs to be, okay, because if we let u be the numerator, well, then how do we get the denominator? And if we let u be the denominator, then the derivative will be 2x. But the numerator is 1 plus x. So you see that's a bit complicated. Okay, but it's not too bad because this is a fraction. Okay, so it's like 1 plus x over 1 plus x squared. We can separate it into 2 fractions. Okay, maybe if we do it in 2 parts, that would be easier. So we have the integral of 1 over 1 plus x squared plus x over 1 plus x squared. Okay, so we just split it up into two fractions. Okay, because maybe each smaller part is easier to do. And we see that, yes, that does help us. Because this first part, we know what that is. So we know how to do that. And the second part, we also know how to do this one. Okay, because like I said before, if you let u be the denominator, then the derivative or du will be 2x. The derivative of 1 plus x squared is 2x. And we see that in the numerator, we have x. So we're almost there. Okay, but very easy to get from 2x to x. So if we let u be equal to 1 plus x squared, then we can do that integral as well. Okay, so you see sometimes we need to split the fractions up because the individual parts is easier to do than everything added together. Okay, so just keep that in mind when you have these fractions to work with. Okay, so let's split this up like we wanted to do. So we can split it up into the first one, which is 1 plus x squared dx, plus the second one, which is x over 1 plus x squared dx. Okay, we're going to do them separately like we wanted to. So let's call this first one 1. We call the second one 2. Okay, so let's take a look at number 1. So we have the integral of 1 over 1 plus x squared. That's super easy. We know the answer right away. That is going to be the inverse tan of x. Okay, I'm not going to write plus c now. We can put the plus c right at the end. Okay, what about number 2? A bit more complicated. The integral of x over 1 plus x squared dx. Okay, so it's a bit more complicated, but we said that we know what to do because if we let u be the denominator, then the derivative gives us the numerator. So we're going to do that. So u is equal to 1 plus x squared. Du is equal to 2x dx. Okay, we don't want 2x dx, we wanted x dx. So we divide both sides by 2. 1/2 du is x dx, which is good. That's what we want here. Okay, so we can write this in terms of u. This will be the integral of 1 over 1 plus x squared. That's just 1 over u. X dx is 1/2 du. Okay, so I've just made the two replacements there. I replaced the 1 over 1 plus x squared, and I replaced the differential part with the x dx. Okay, now we can take the 1/2 out. We're left with the integral of 1 over u du. Okay, we know how to do that. That's going to be 1/2 the natural log absolute value of u. Okay, again, I'm not going to put the plus c now. I'm going to put it right at the end. Okay, but we're not done yet. The u needs to be replaced with the x function. So u is 1 plus x squared. We need to put that back. So this is going to be 1/2 the natural log of 1 plus x squared. Okay, so we've got our answer for the first integral. We've got our answer for the second integral. We can just add the two parts together. So this becomes, the first one was inverse tan. And the second one was 1/2 the natural log of 1 plus x squared. Sorry, 1 plus x squared. And now we can add the plus c. Okay, so you see sometimes it's easier if you split the integral into two smaller problems, and then you can solve each smaller problem separately. And then right at the end, you just put everything together again. Okay, any questions on this one? Okay, I've got a question here. So can you please re-explain? Yeah, sure, no worries. Let's go over that one again. Okay, so we're just doing number 3 again. So we have the integral of 1 plus x over 1 plus x squared dx. Okay, so remember, we're going to try to use the U-substitution, but there's a problem here. If we let u be the numerator, then there's no way of writing out the denominator nicely. Okay. If we let u be the denominator, then the derivative will be 2x. However, the numerator is 1 plus x. Okay, so that's a problem. So what we do instead is we try and separate this fraction into 2 parts and do them separately. See if that helps us. So this fraction we can write as 2 fractions being added together. So the first one is 1 over 1 plus x squared. And the second one is x over 1 plus x squared. Okay, so we've split it up into 1 and 2. Okay, so we've just separated the fraction. So what we can do now is separate this into 2 integrals. Okay, because we've just added 2 functions together, we can separate that. So this becomes the integral of 1 over 1 plus x squared dx plus the integral of x over 1 plus x squared dx. So we have integral number 1 and integral number 2. Okay, because the original one was too complicated, if we separate it out into 2 integrals, we will see that integral 1 is easier to do, integral 2 is easier to do, then we can just add them together. Okay, so let's take a look at these 2 separately. So integral number 1 is the integral of 1 over 1 plus x squared. Okay, we've seen this before. This is a very standard integral. So the integral of 1 over 1 plus x squared is just inverse tan x. Okay, I'm not going to put the plus c now because we're going to add our 2 answers together and then I can put the plus c. Okay, so we can save that for the end. Okay, so that's part 1. That was easy to do. What about part 2? We have the integral of x over 1 plus x squared dx. Okay, so now we can do a U-substitution because we see this bottom part is 1 plus x squared. The derivative of 1 plus x squared is going to be 2x. Now in the top, we have x, but with a little bit of manipulation, we can get from 2x to x. So that's not a problem. So let's see what I mean by that. So u is equal to 1 plus x squared. That's the denominator. We also need to find the differential. So that means we need to find du. So du is going to be 2x dx. Now you see in our integral, we have x dx. But here we have 2x dx. Okay, we've got that extra factor of 2. But that's no problem. We can just take the 2 over to the other side. 1/2 du is x dx. Okay, now we're happy with that because we've got x dx in our integral. We've got x dx over here. That's what we want. Okay, so let's make the replacement. So this becomes the integral of 1 over 1 plus x squared becomes 1 over u. X dx becomes 1/2 du. Okay, I've just done the replacement. I've changed the function. I've changed the differential. Okay, no problems with that. Now this 1/2 we can take out, and we're left with 1/2 the integral 1 over u du. Okay, that's easy to do. The integral of 1 over u is the natural log. So that's going to be 1/2 the natural log absolute value of u. And again, I'm not going to put the plus c now. I'm going to put that right at the end. Okay, but we're not done yet because we've got this in terms of u. What we really want is this in terms of x. So let's put that back. So this is going to be 1/2 the natural log of 1 plus x squared. Okay, so we've got the answer for part 1. We've got the answer for part 2. So now we can just add them together. So the integral of 1 plus x over 1 plus x squared is going to be that first part plus the second part. The first part was inverse tan of x. The second part was 1/2 the natural log of 1 plus x squared. Okay, and now since we're writing down our final answer, we need to put the plus c. Okay, so as long as you have the plus c right at the end, then that's fine. Okay, any questions on this one? Okay, let me just look at the chat quick. Okay, no questions there. Okay, so all of these have been the U-substitution with indefinite integrals. Okay, so the last example for today, we're going to look at U-substitution with definite integrals. Okay, so what happens if we have the bounds? Okay, so this is number 4. So we have the integral from 0 to 1, 1 plus 7x to the 1/3. Okay, we do the same thing as before. So we look at what is the inside function. So we've got something complicated here to the power 1/3. It would be really nice if this inside part wasn't there. So this inside part, the 1 plus 7x, we're going to replace that with u. So u is equal to 1 plus 7x. Okay, but we can't just do that. We've got the differential as well to worry about. So du is 7 dx. Okay, we don't have 7 dx. We've just got dx. That's not a problem. We can take the 7 over to the other side. 1 over 7 du is dx. Okay, which is what we wanted. Okay, but if it's a definite integral, we also need to change the bounds. So if x is equal to 0, that means u is equal to 1. If x is equal to 1, that means u is equal to 8. I've just substituted into here. So we've got ourselves the new lower bound, and we've got ourselves the new upper bound. Okay, so we've got all the pieces to put inside our new integral. So we have the integral. What is the new lower bound? That's going to be 1. What's the new upper bound? It's going to be 8. 1 plus 7x, that becomes u. But we have 1 plus 7x to the 3rd, so that's u to the 3rd. dx becomes 1 over 7 du. Okay, so I've just looked at what was there previously, and I've made the replacements or the substitutions. Okay, so now we can take this 1 over 7 out. So we have 1 over 7, the integral from 1 to 8, u to the 1/3 du. So we have 1 over 7. We add 1 to the exponent. That makes it 4 over 3. Divide by that, we get 3 over 4. U to the 4 over 3. And this gets evaluated from 1 to 8. Okay, so 1/7 times 3/4, that's going to be 3 over 28. Then we substitute the upper bound, so that's 8 to the 4 over 3 minus 1 to the 4 over 3. Okay, so that's going to be 3 over 28 times 16 minus 1, that's 15. So we end up with 3 times 15, that's 45. So we have 45 over 28. Okay, so you see, we don't need to replace anything. So over here with the u, we don't need to put anything back because we've already changed the function and the bounds. Okay, so there's no need to go back to x. We've made our change, we've substituted the bounds, and we get our number in the end. Okay, so it's only with indefinite integrals that we need to go back to x. For definite integrals, we've changed the function and we've changed the bounds, so everything's fine there. Okay, so that's it for today. I will upload this video shortly and you can go through it again. Remember, tomorrow we don't have a lesson, but I have uploaded the worksheet for you to go through. Okay, and then we'll carry on with lectures on Tuesday. Okay, because Monday is a public holiday. Okay, if you do have any questions, please let me know in the group. Okay, bye everyone. I'll see you on Tuesday.